Today we're going to be relating linear context to graph features. So what we really have to be focused on, there's really just four different things you can run into. One's the y-intercept. That's usually like a starting point, but x is 0, the input value is 0. So we're really going to be focused on what is x represented by and what is y represented by. If you get that down, it's going to help quite a bit. Then the rate of change is the slope. They give you the slope, that's the rate of change. X-intercept is when the output value is 0, and also usually it's the ending value as well. And then they might also just give us some other point on the graph. So in order for it to be an x-intercept or a y-intercept, one of the coordinates has to be 0. So a y-intercept x has to be 0, x-intercept y has to be 0, and then in order for it to be slope, it has to be a rate of change. So let's look at this first problem. A lake near the Arctic Circle is covered by a 2-meter thick sheet of ice during the cold winter months. When spring arrives, the warm air gradually melts the ice, causing its thickness to decrease at a constant rate. After 3 weeks, the sheet is only 1.25 meters thick. Now this next part's the important part. Let y represent the ice sheet's thickness, and then x is the number of weeks. So here's what we have. We have that the x coordinate is the number of weeks, and the y value is the thickness. So let's look and see what's given. We're given that a lake near the Arctic Circle is covered by a 2-meter thick sheet of ice during the cold winter months. When spring arrives, the warm air gradually melts the ice, causing its thickness to decrease at a constant rate. They didn't tell us that rate, so they didn't give us the slope. If they told us the rate was, an inch per day or something like that, now they've given us a rate, but they didn't give us a rate. Instead, they gave us that after 3 weeks, the sheet of ice is only 1.25 meters thick. So we're starting with, and that's a starting point, is usually the y-intercept, right? The starting point is the y-intercept like I was saying earlier, and then it begins to decrease. So we're starting with the point. So before we even start our weeks here, we're already 2 meters thick, right? That's before we even start. And then after 3 weeks, so after 3 weeks, it's down to 1.25 meters thick. So what do they give us here? They give us 2 points, but we know that this one is the y-intercept because that's starting point. So looking here, they didn't give us slope and y-intercept, slope and y-intercept, or x-intercept. Slope and a point that's not an intercept, no. X and y-intercept, no. Y-intercept and a point that's not an intercept, that sounds right. See, we got the y-intercept, and we got a point that's not an intercept. Let's look at this one. A charity organization had to sell 18 tickets to their fundraiser just to cover necessary production costs. They each sold a ticket for $45. Let y represent the net profit when they have sold X tickets. So X is the number of tickets, and Y is the profit. And I'm looking at this, and it says that they had to sell 18 tickets. So in order to the fundraiser, just to cover the necessary production costs. So in order to have zero profit, in order to have no profit at all, they had to sell 18 tickets. Doesn't this look a lot like an x-intercept? Just covering your costs means you don't have profit, right? So no profit means 18 tickets were sold. That's what this is telling me right here. Then they sold each ticket for $45. That's a rate. It's $45 per one ticket, right? That's your slope, 45 for every one ticket. So this is the x-intercept and the slope. All right, Hero painted his room after 3 hours of painting at a rate of 8 square meters per hour. So you can see right there, boom, slope. M equals 8, right? Square meters per 1 hour. he had 28 square meters left to paint. So after 3 hours, so right here, after 3 hours, he had 28 square meters left to paint. So y is the area and x is the hours. So then we're given the point with 3 hours, there was still 28 left to go. So that's just a point and a slope. That's not an intercept. So we have, let's see, slope and a point that's not an intercept. There we are. Conrad read a 180-page book cover to cover in a single session at a constant rate. It took him 6 hours. Let y represent the number of pages left to read after t hours. So he read a 180-page book cover to cover. So y represents the number of pages, and t represents hours. So the x value is hours, and y is the number of pages. So in 0 hours, he would have read 180, or he would have 180 pages left, right? Because y is the number of pages left to read, so there's 180 pages left to read before he even reads it at all. And then at a constant rate, it took him 6 hours to read the book, so after 6 hours, there's no more pages. So what you can see there is this is both the x and the y-intercept.